So we're working with radical equations. We see what happens when we have a variable under a radical. We got to do the opposite to both sides. We've got to square both sides, or sometimes cube, whatever the index is. So now we want to look at a situation where we have variables inside and outside the square root. All right. So, well, the key here is we want to isolate the radical first. Just like we've been doing, we did before. We had to get that radical all by itself. So let's do that. We can add x to both sides. Remember, x is just a number. So we can move it in the same way as a number. And so that leaves us with 6x plus 7 equals 2 plus x. Or actually, I'm going to write that as x plus 2. Doesn't really matter, but you'll see why. All right. Now we got the radical all by itself, so now we can square that. And so we end up with 6x plus 7 equals, now do you remember how to square this radical? We have a rule we can use, or we can just write it out. So we have x plus 2 times x plus 2. And we've got to distribute that. Okay, don't just square the x and square the 2. So this comes out to x squared. We have 2 times x is 2x. We have another 2 times x. And we have a 2 times 2. And we get 4x. All right. Now, we can also use our rule for squaring binomials. Now, remember, a rule is just a pattern that we found. So we've squared out, if you square out a plus b times a plus b, you're going to get a squared plus 2ab plus b squared. And that's going to be a useful thing, as we'll see down the road here. All this says is that anytime you're squaring this, you're going to get the first thing squared, the last thing squared, and 2 times their product. Okay, so let's see how that can be applied here. So in this case, if we have x plus 2 squared, this rule tells us that we square the first thing. Okay, so we're going to have the first thing squared. The first thing here is x. We're going to square the last thing, or the second thing, in this case the 2. 2 squared is 4. And then we've got to have 2ab. That's 2 times their product. Well, this is a, this is b. So their product is 2 times x. So I'm going to write that as 2 times 2x. And so in the end, we end up with x squared plus 4x plus 4. Now you might say, well, that's not much more work, or much less work, I should say. But it's going to help us to start to remember that rule that will help us. All right, so we end up with x squared plus 4x plus 4. Now, a little side note, speaking of side notes, I'd recommend that you be careful and in general, avoid doing little side problems like this. We want to keep everything together when you're solving equations. Keep working down the page and avoid this. I did this just kind of for teaching purposes, for clarity. But I would recommend keep it all together, all right? Because a lot of times when we pull things apart and try to bring them back together, they don't come together right. That's where a lot of mistakes happen. So be careful. All right, so let's, what's going on here? We got a quadratic equation. Quadratic means x squared. So that x squared gives us a different situation. Now, hopefully we have a little experience with that. We're going to get into that in a future chapter in detail. But the key here, when we have a quadratic, we want to get everything to one side. We want to make it equal to 0. Going to make it equal to 0, and then we're going to factor. All right, that's going to be our approach right now. We'll get into more methods soon. All right, if it's been a while since you've solved a quadratic equation, you may want to go check out just a video on how to do that. So we want to make this equal to 0. So we want to get all of this out of there. We want to get everything onto the side with the x squared. All right, so whatever side the x squared is on, we're going to move things that way. All right, so we're going to subtract 6x from both sides, and we're going to subtract 7 from both sides. And that'll leave us with 0, and negative 2x, and negative 3. Now, how do we solve that? All right, so again, we gotta approach a quadratic equation a little differently. So the key is this: we're going to factor. Factor means we need to write it as two things multiplied. So we're going to factor here. Now to factor this is a quadratic trinomial. We need to look for two numbers that add to -2 and multiply to -3. So a little review on factoring or solving by factoring. If we have a quadratic trinomial, x squared plus something, x plus something, we're looking for two numbers that add to b and multiply to c. And when you find those two numbers, we're going to factor it out as x plus m and x plus n. Okay. Now it might be plus, it might be minus, but we'll see how that works. Okay. So factoring. Are there two numbers that add to -2 and multiply to -3? Well, we think about numbers that multiply to -3. We've got 1 times 3. That's it, right? Okay, so we know that this is going to be a 1 and a 3. Now, it needs to multiply to -3, so we have a couple options. We could make this a -1 times a positive 3. Now, we've got to double check. Does -1 plus -3 make, or does it add to -2? Nope, they don't. All right, so our signs need to be fixed here. So it's not going to be a minus, and it's not going to be a plus. All right, so what signs should we use? Well, let's switch that up. Let's try making that a plus, making that a minus. We know they need to be different because that's a -3. So positive 1 times -3 is -3, and those do add to 2, -2 that is. So these two add to -2, so we found the right numbers. Now, a little review on the solving by factoring here. Notice this, we've got two numbers. In the parentheses, x plus 1 is a number, x minus 3 is a number, and they're being multiplied. So if you have two numbers that you can multiply to make 0, okay, if we say this, let's say I have a times b equals 0. If I told you I'm thinking of two numbers that multiply to 0, what do you know about one of the numbers? Well, one of them has to be 0. So it's either 0 times b or a times 0. One of these has to be 0 if they multiply to 0. Okay? So we ask ourselves, well then, what do we need in order to make x plus 1 equal to 0? And the answer is -1. What do we need to make x minus 3 equal to 0? And that is add 3 to both sides, we get 3. All right, so there's a quick review on solving by factoring. All right, so we get two answers. All right, well, let's go back and look at our original equation because we do have to check this. The original equation wasn't a quadratic equation, it was a radical equation. So we do need to check this. Okay, and so we have the square root of 6 times -1 plus 7 minus -1 equals 2. Just plugged -1 in for all the x's up here. Okay, let's work that out and see if that comes out to be what we want it to be. So this is 6 times -1 is -6 plus 1, or plus 7, sorry. That is the square root of 1. Minus -1, how about I write that as plus 1? And this is looking pretty good. We got 1 plus 1, and that is 2. Should put a question mark there. We didn't know if it's equal, and yes, indeed it is. What about 3? So we're going to plug 3 in for all of the x's. Everywhere there's an x, we're going to plug in 3. And let's see if that works out. So we get the square root of 6 times 3 plus 7 minus 3. Is that equal question mark to 2? And this comes out to be the square root of 3 times 6 is 18 plus 7 is 25. Minus positive 3, is that equal to 2? Well, this is 5 minus 3, and yes, indeed, that does work out. All right, so both solutions work. We can keep them both. We don't have to throw any of them out, and that's the key there, all right? So that's how we solve with variables inside and outside of the radical, that is.